Let's unpack a paper titled Attention is All You Need. What's the core idea here?
Well, the big idea in this paper is that we can build a really effective sequence transduction model without using recurrence or convolutions, the usual suspects, right? And instead just rely on attention mechanisms. The paper shows that in the context of machine translation, this new approach not only performs better than RNNs, but also trains faster.
That's super interesting, especially considering the time this paper was published. It's from 2017, right? What was the state of sequence models back then?
Exactly, 2017. Back then, everyone was all about RNNs, recurrent neural networks, think LSTMs and GRUs. These models were the top dogs for tasks like language translation and text summarization. But these RNNs had a bit of a bottleneck. They were tough to train on long sequences because they had to process everything in order, one step at a time. And that was a big limitation.
How would the Attention is All You Need paper address this sequential processing bottleneck of RNNs?
So instead of going step by step like RNNs, they introduced a model called the transformer, hence the title. The transformer processes the entire sequence all at once by using something called self-attention. It's like giving the model the ability to look at all parts of the input simultaneously and figure out which parts are most relevant to each other. Kind of like having a bird's eye view of the entire context, which is awesome for capturing those long-range dependencies between words in a sentence.
This self-attention mechanism sounds powerful. How does self-attention work in the transformer model?
It's a bit like how we focus on different parts of a picture to understand it. Each word in the sequence looks at other words and assigns them different weights, kind of like voting for the most important words in the context. The really cool part is that these weights are learned by the model during training.
So it's a bit like the model is learning to focus on what's important, like a spotlight for language. Can you tell a bit more about how the model learns these weights?
Yeah, it's all about the query, key, and value concept. These are vector representations for each word in the input sequence. The attention weight for each word is calculated based on the compatibility between the query and key vectors, typically using dot product. The value vectors, weighted by the attention scores, are then combined to produce the output.
Are there any other advantages to using the transformer model?
You bet. As demonstrated in the paper, the transformer allows for the parallelization of the training process, which can lead to faster training times, especially on GPUs. This is a huge advantage over RNNs, which have to process everything sequentially, like we discussed before.
I see the paper mentions something called multi-head attention. What's that about?
Great question. Multi-head attention is a clever extension of self-attention. Instead of just having one mechanism of attention, the transformer uses multiple attention heads, hence the name multi-head. Each head learns to pay attention to different aspects of the input, which gives the model a richer understanding of the relationships between the words, and this leads to a more robust and nuanced understanding of the input sequence. Pretty neat, eh?
That is pretty neat. So in terms of results, how did the transformer perform on the translation task?
On the WMT 2014 English to German translation task, it set a new state-of-the-art blue score of 28.4, which was a big deal at the time.
They also applied the model to English constituency parsing, right? Why did they do that?
Yes, the paper's authors applied the transformer model to English constituency parsing. This was done to assess the transformer's adaptability to tasks beyond translation, specifically those with strong structural constraints like parsing.
And this closes our discussion of Attention is All You Need. Thank you.